Mr. Ahmed here again. Video number 2, also for use with our 8.3 homework. We're still going to be working with quadratic functions. However, our goal today is going to be to graph a quadratic function in standard form. So a brief reminder, standard form is ax squared plus bx plus c. So we see we have an x squared, also an x. All right, so for us to graph, we are going to take 4 steps in the process of graphing a quadratic function. The first thing we need to do is we are going to use the standard form to locate the axis of symmetry. Keep in mind the axis of symmetry is that vertical line that divides the graph in half. 2 parts where if I folded it right on top, they'd land on each other. The axis of symmetry is found by taking x equals negative b over 2a. So when I look at the quadratic, the b is in front of the x, the a is in front of the x squared. The coefficient of x squared, the coefficient of x, the c is just a constant, so it's just going to be a number. After we find the axis of symmetry, we are going to find the vertex. The way that we find the vertex is we plug the x value of the axis of symmetry into the original equation. Okay, I have to plug it back in. After we're done plugging it back in, we will then make an XY chart with the vertex as the middle point. We're then going to find 2 points above it and 2 points below it. We'll plot our points and then draw our graph. Our graph should always look like a U. It does not look like a V. If you end up with something that looks anything unlike a U opening up or a U opening down, we made an error. And we have to be super careful when we plug these points back in. Okay? Have to be careful. Make sure we use parentheses. So hopping right into our very first example of how to draw a quadratic graph. Our equation is f of x equals x squared minus 2x plus 4. So the first thing I'm going to do is I'm going to identify what a is, what b is, and what c is. Keep in mind, standard form is ax squared plus bx plus c. So our a is the coefficient in front of the x squared. In this case, there's nothing there, so we have a 1x squared. So a is equal to 1. B is in front of the x. In this case, it's negative 2. And our c is equal to 4. First step is to find the axis of symmetry. The equation x equals negative b over 2a. We have to plug in our values we just found for a, b, and c. So in this problem, our negative b is going to be a negative 2, which will change to a positive. All over 2 times a is 1. That translates to positive 2 divided by 2, which is 1. So the axis of symmetry is the line x equals 1. Keep in mind that's a vertical line. Our axis of symmetry is always a vertical line. Our next step is to find the vertex. So we take this x value we just found of 1 and we plug it into the original equation. So our original equation, when I plug it in, f of x, just like a y, so y equals, we're putting 1 in for x. Okay, put 1 in. So we have parentheses around our x squared. We have 1 squared minus 2 times 1 plus 4. Make sure you follow the order of operations as you simplify this down. You have to do the exponents first. And this works for every single problem. If you type this into a calculator, make sure you put the parentheses in. You could type in this entire expression into your calculator, but you have to use the parentheses. When I simplify this down, y is equal to 3. I didn't go through each little step to simplify that. I'm under the impression we can do that. If you have trouble with that, use your calculators. Just make sure you use the parentheses. You're going to have to do this many times throughout the graphing process, so it needs to become fairly quick. So our vertex is the point 1, 3, because we just found y is 3 when x was 1. So I'm putting that in the middle of my graph. 1, 3. Now we have to find some values lower. So numbers smaller than 1 consist of 0, -1, and bigger, 2 and 3. So I picked these values of x. I picked the values of x based off the vertex. We knew this was the vertex, 1, 3. We then had to pick 2 numbers smaller and 2 numbers bigger. After that, plug in the x values to find y. Keep in mind, you have to use the parentheses. So when I substitute in -1, it would look like this. Parentheses, -1 in for x squared, minus 2 times -1 in parentheses, plus 4. When you simplify that down, y is 7. 0 is always the easiest one to put in. So when I put in 0, we have 0 squared minus 2 times 0 plus 4, and our value is 4. Now, considering I picked the same distance away from the vertex here at 0, that was 1 away, 2 away, 1 bigger, 2 bigger, these values should end up being the same. So when I substitute it in parentheses, 2 squared minus 2 times 2 plus 4, that's all based off our original equation. When you simplify it down, y is equal to 4. Same process with our 3. 3 goes in for x. 3 squared minus 2 times 3 plus 4. Plug those in with the parentheses, and we get 7. So, to draw our graph, first point I want to plot is my vertex. Over 1, up 3. Our axis of symmetry is the line x equals 1. It goes right through the vertex. So we should have a u either opening up or a u opening down, with this being either the highest or the lowest point. My next point I'm going to plot, 0, 4. So it looks like it's opening upward. We also have the point 2, 4. Notice, I went up 1. It's 1 away from the axis of symmetry. 1 away from the axis of symmetry. And then my next point is -1, 7. 2, 3, 4, 5. And that goes off the graph by 1, so I'm just putting it up a little bit higher. And my last point is 3, 7. So over 1, 2, 3, up 7. And again, that one went off the graph a little bit. When you draw this, draw it as a nice U. We do not want a V. It's curved. And then it keeps going up forever and ever and ever. So, do we have a maximum or a minimum? It's opening upward, so we have a minimum. The minimum was the point. Y equals what? The minimum was y equals 1, 2, 3. So the minimum, we're going to call that the point. 1, 3. For this y value, a little bit confusing the way it's written, we're looking for the y-intercept. Where is the y-intercept? Crosses the y-axis at 4. That is the y-intercept. First graph is done. The hardest part is definitely going to be plugging in your points. You just have to be super careful with your parentheses. We are going to do one more, and then there's a U try. Keep in mind, the answer for the U try is indeed posted on PowerSchool Learning, so if you would like to try that one out, feel free, but I will not be putting it on the video. Makes them a little bit long. So this one's going to go a little bit quicker. First step, identify our A, B, and C. In this case, ax squared plus bx plus c, standard form. A is equal to 3, b is equal to 6, c is equal to -1. We have located our A, B, and our C. I did not do a very good job of including that in the video. It was a little bit off the screen. Ax squared plus bx plus c. A is 3, b is 6, c is -1. Next step, find the axis of symmetry. Formula, x equals -b over 2a plug in our values. In this case, b is 6, so we have negative 6 over 2 times a is 3. And that's equal to negative 6 over 6, which is negative 1. So the axis of symmetry is the line x equals negative 1. I'm going to draw that right away. Negative 1, vertical line. Now that our axis of symmetry is drawn, we're going to find our vertex by plugging in the x value from the axis of symmetry into the original equation. So in this case, we have 3 times x has to be negative 1 squared plus 6 times negative 1 minus 1. Make sure you use the parentheses. After we plug that value in and simplify, we should get, I'll actually do this one out the whole way. Follow the order of operations. Negative 1 squared is 1. So we'd have 3 times 1 plus 6 times negative 1 is negative 6 minus 1. Now when you add and subtract from left to right, we'd have 3 plus negative 6 minus 1. 3 plus negative 6 is negative 3 minus 1. We get negative 4. So that would be how I do it by hand. So our vertex is the point negative 1, negative 4. So that's going to be my middle point, negative 1, negative 4. Now picking some values smaller, negative 2, negative 3, bigger, 0, 1. As you plug these in, I'm just going to say what they are. You can use your calculator, just make sure you use the parentheses. When we put in negative 2, we get negative 1. When we put in negative 3, we get 8. Also down here, negative 1 and 8. Next step, plotting our points. Plot the vertex first. Left 1, down 4. My next point I'm going to plot is 0, negative 1. And then my next point over here, negative 2, negative 1. Then I have the point 1, 8, which is off of our graph. So over 1 up 8. Just go up a little bit. And we also have the point negative 3, 8, which is off the graph by a little bit. When you draw in your graph, nice gentle curve for a U, don't make it a V. It keeps opening up, get it close, call it good. In this case, it's opening upward. So again, we have a minimum. And our minimum value for Y is negative 1, 2, 3, 4. Okay, and for this part again, I'm just going to identify the y-intercept. And the y-intercept is the point 0, negative 1. And that's all we have for today. Like we said, if you'd like to try the last example, feel free. Otherwise, it is uploaded on PowerSchool Learning, totally filled in with your completed notes. Have a great rest of the day.